There is a place where two nations meet at the edge of a great river, where the water runs so deep and so fast that the ground itself seems to tremble. The Paraná River, one of the mightiest waterways in the Western Hemisphere, drains a basin larger than the entire state of Alaska. It carries more volume than nearly any river outside the Amazon. And along its banks, in the latter half of the 20th century, engineers dared to imagine something that had never been attempted at such scale, a structure so vast, so technically demanding, that the building of it would alter the course of rivers, the balance of nations, and the lives of millions. That structure is Itaipu. Its name comes from the Guarani language, the tongue of the indigenous people who long called this river valley home. It means the sounding stone, named for an island that once stood near the construction site, an island that no longer exists. The name carries a quiet poetry, stone that makes sound, rock shaped by the force of water. There is no better metaphor for what was built here. To understand why Itaipu was built, you have to understand the world of the 1960s. Brazil was a nation accelerating toward an industrial future. Cities were expanding, factories were multiplying. The demand for electricity was growing faster than the existing power grid could answer. Paraguay, its smaller and landlocked neighbor to the west, shared the Paraná River as a common border, a border that had been contested, fought over, and finally settled through generations of difficult history. Both countries looked at that rushing water and saw something neither could develop alone. On July 22, 1906, Brazilian Foreign Minister Juraci Magalhães and his Paraguayan counterpart, Raul Sapena Pastor, signed the Iguaçu Act, a formal declaration of mutual intent to study and harness the hydro resources of the shared Paraná River. It was a diplomatic beginning, cautious in its language but enormous in its ambition. 7 years of studies, negotiations, and technical planning followed. A consortium of Italian and American engineering firms, ELC, Electroconsult, and IECO, won the international competition to conduct feasibility studies, beginning their work in February 1971. Finally, on April 26, 1973, Brazil and Paraguay signed the Itaipu Treaty. It was more than a construction agreement. It was a bond between two sovereign nations, each staking its energy future on a shared and irreversible commitment. There was also a third voice at the table. Argentina, downstream on the Paraná, watched the project with deep concern. A dam of this scale would alter river levels across the entire watershed. After years of tense diplomacy, a landmark agreement, the Tripartite Accord, was signed by Brazil, Paraguay, and Argentina on October 19, 1979. It established precise limits on how much river levels could change as a result of hydroelectric operations. That agreement did something larger still. The process of resolving the dispute laid the groundwork for Argentine-Brazilian integration, a relationship that would eventually flower into the Mercosur trade bloc. Itaipu's shadow stretched far beyond its concrete walls. Construction began in January 1975, but before a single turbine could turn, engineers faced a problem of almost theatrical audacity. You cannot build a dam while a river is still flowing through the place where the dam must stand. And the Paraná was not a modest stream. It was one of the most powerful rivers in the world. On October 14, 1978, workers completed one of the most remarkable acts of civil engineering in modern history. They diverted the Paraná River itself. A bypass channel nearly 2 kilometers long had been excavated to redirect the river's full force away from the construction zone. When the diversion was complete, a section of the ancient riverbed, a corridor of earth that water had shaped for millennia, stood dry for the first time. Into that exposed ground, engineers poured the foundation of the most powerful hydroelectric dam on Earth. What rose from that riverbed over the following years was staggering. The main concrete barrage climbs 196 meters, taller than most skyscrapers. When you include the cranes and structures atop the dam, the total height reaches 247 meters. The dam stretches nearly 8 kilometers across the valley when all its structural components are measured together. The reservoir it holds back covers more than 100 square kilometers. The hydraulic design head, the difference in water elevation between the reservoir surface and the river below, stands at 118 meters, generating pressure that drives turbines with relentless force. 20 generating units were eventually installed inside the dam's powerhouse, each one a turbine and generator pairing capable of producing 700 megawatts. Together, they represent an installed capacity of 14 gigawatts. To place that in human terms, the entire volume of the famous Iguacu Falls, the thundering cascade that draws millions of tourists just kilometers away, could only generate enough force to run 2 of Itaipu's 20 generators. There was a technical complication born of politics and geography. Paraguay uses 50 hertz electrical current. Brazil uses 60 hertz. 1 dam, 2 countries, 2 incompatible systems. Engineers solved this by dividing the powerhouse. 10 generators for Paraguay at 50 hertz, 10 for Brazil at 60 hertz. But Paraguay's economy, while growing, could not absorb the electricity its generators produced. The surplus was enormous. So, 2 high-voltage direct current transmission lines, each stretching nearly 800 kilometers southward, carry that excess power down to the vast industrial regions around Sao Paulo and Rio de Janeiro, where converter stations transform it into the 60 hertz current that Brazilian homes and factories require. Itaipu did not merely power 2 countries. It became the central nervous system of South America's largest economy. The human cost of building this monument was profound and, for many, irreversible. When construction began, approximately 10,000 families living along the Paraná River were displaced. Their homes, their fields, their communities, swallowed by the rising waters of the reservoir that began filling on October 13, 1982, when the side canal gates were closed. Heavy rains accelerated the filling dramatically. Within 2 weeks, the water had risen 100 meters and reached the gates of the spillway. But the deepest loss came from what the reservoir consumed permanently. The Guaíra Falls, known in Guarani as Salto del Guairá, were the largest waterfall in the world by sheer volume of water. Not the tallest, not the most famous, but the most powerful. The Paraná poured over them in a roar that could be heard for miles. In the weeks before the reservoir sealed them forever, tourists flooded the area for a final glimpse. An overcrowded bridge overlooking the falls collapsed under the weight of the crowd. 80 people lost their lives. The falls themselves vanished beneath the rising water shortly afterward. The Brazilian government dissolved the Guaíra Falls National Park. There was nothing left to protect. The ecological consequences ran deeper still. The falls had functioned as a natural barrier between 2 distinct freshwater ecosystems, each harboring species found nowhere else on Earth. When the barrier disappeared, species from below the falls began invading the waters above. More than 30 fish species crossed into regions they had never occupied before, disrupting food chains and ecological balances that had taken thousands of years to develop. On May 5, 1984, the first generation unit at Itaipu came online. 2 to 3 units were added each year until 18 were running by 91. The final 2 units entered service in 2006 and 2007, completing the powerhouse and raising installed capacity to the full 14 gigawatts. Under the terms of the 3-nation accord, no more than 18 units may operate simultaneously. 2 are always offline for maintenance, a diplomatic constraint written directly into the dam's operating procedures. The records this facility has set are staggering. In 2016, Itaipu produced 103.1 terawatt-hours of electricity, the highest annual output ever recorded by any hydroelectric facility in the world at that time. That record stood until 20, when China's Three Gorges Dam, swollen by historic monsoon rains, produced 111.8 terawatt-hours. Between 2012 and 21, Itaipu averaged 89.22 terawatt-hours per year, consistently second in the world. At various points, it has supplied nearly 3/4 of Paraguay's total electricity and close to 17% of Brazil's. An astonishing dependency for a nation of that size. In '94, the American Society of Civil Engineers named Itaipu one of the 7 modern wonders of the world. The recognition appeared the following year in Popular Mechanics magazine. The American composer Philip Glass was moved to create an entire symphonic cantata in the dam's honor. Today, ecological corridors connect the protected margins of Lake Itaipu to the Iguacu National Park and beyond, threading conservation through a landscape permanently altered by human ambition. The Itaipu Treaty expired in 2023, reopening the long and unresolved question of how 2 nations share not just a river, but the wealth it generates. Paraguay has long argued the terms were unequal. The negotiations continue. The river does not wait. What was built here, on the bones of a diverted river, above the grave of the world's greatest waterfall, is one of the most consequential structures ever raised by human hands. Concrete and steel and moving water, producing power every hour of every day, serving tens of millions of people across two nations who may never pause to consider what it cost. But the cost is worth knowing, and so is the name, Itaipu, the sounding stone. If you found this history worth knowing, subscribe for more stories of human ambition in steel, stone, and concrete.